Hello everyone, welcome to AI Portal, your gateway to the world of artificial intelligence. Today we are going to discuss the lightweight open source model released by Google called Gemma. Gemma 2 billion is a 2 billion parameter decoder-only language model that has been developed to work with CPUs and mobile devices. We will perform a few small tests on the model and see how it responds to our prompts. Please note that this is not a full comprehensive testing, but we will just give a few basic prompts for NLP use cases like text analysis, common sense reasoning, and coding. Before we go any further, why are we testing this? So basically, language models are evaluated using certain benchmark datasets. These datasets have various tasks like question answering, math problems, and coding. Just because the language model has had high scores on these datasets doesn't necessarily mean that they will work well for your particular use case. It is always better to make some basic tests before deciding to go with a particular model. Now let's get into my experiments with Gemma 2 billion. This is the collab where we perform our experiments. So if you see, I start by installing the necessary packages. We install the Accelerate package, and then we also need to install the Hugging Face Hub because Gemma models are gated models, which means that you need a Hugging Face token in order to access them. So for that, you need to create an account on Hugging Face and then call the login method where it will prompt you to give a token. You give the token and then your login is successful. After that, you load the tokenizer and the model. So if you observe the name of the model, it's Gemma 2B IT. So IT here stands for instruction fine-tuned. So this is not a base model, but they took the base model and they have fine-tuned them with instruction-based datasets. That means it is now equipped to follow your instructions. So I have written a method here so that we can test multiple prompts. It takes the prompt, tokenizes it, feeds it into the model, and then decodes the tokenizer's output. So we get back English language text. So if you observe here, I have given maximum new tokens as 8,192. This is the context size allowed by the 2 billion model, which is great because similar models with similar number of parameters usually have only 2,048 tokens. So this just means that we can give more context in the prompt, and also we can also test prompts with a lot of text. So we will be using this method for testing the outputs for various cases. So let's start with question answering. So here what we do is we call the method with a prompt. So the prompt is structured like this. So this is the instruct keyword. And here is your instruction, and here is your actual question, because here it's the question answering. And here you will get the output. So if you see the output, when we ask what is the capital of Greece, it tells us that it's Athens, and Athens is the largest city in Greece, and it's the capital. Now the next question we are asking is, who is the current president of United States? And it doesn't give any answer, but it just tells you that the context does not provide any information about the current president, and since it cannot perform Google search, it cannot answer the question. So I cannot answer the question from the context. So that was with question answering. And the next use case is sentiment analysis, where in the first sentence we give a negative sentiment and we see if the model correctly identifies it. If you see, we are following the same format of giving instruct followed by the instruction and then the output. And here the model correctly identifies the sentiment as negative, and it also tells you why it is negative. If you see the next sentence, if you read the sentence, despite the cozy atmosphere and attentive service, the food was a bit underwhelming. However, the chef did show promise with some innovative flavor combinations. So basically, this sentence has a mixed sentiment. So we would have liked the model to give the same, to say that the reviewer, he liked he liked a part of the service, but he didn't like a few other parts. But it just says the sentiment of the text is negative. But I think for a 2 billion model, this is kind of expected. Maybe we will get a different output when we try the 7 billion version of Gemma. So the next use case is common sense reasoning. So here I am just giving a sentence and I'm asking it to fill it up with a possible explanation or possible continuation. So here instruct, what is the continuation of the given sentence that makes the most sense? She opened the window and a gust of wind blew in. So the output we get is she opened the window and the wind blew in, creating a refreshing breeze. This makes sense. So I think this is a good completion. For the next, we also ask it like a trick question, and we will read what the question is. So it's a simple reasoning question. So let's read it. So as an instruction, I gave follow the reasoning in the paragraph below and answer the question at the end. So if you read it, John and Mark are in the room with a ball, a basket, and a box. John puts the ball in the box, then leaves for work. While John is away, Mark puts the ball in the basket and then leaves for school. They both came together later in the day, and they do not know what happened in the room after each of them left the room. So the question is, where do they think the ball is? So here my intention was to ask, what would John think and what would Mark think separately? But the model understands it differently, and it just answers that the ball is in the box. So it also gives us an explanation. The paragraph explains that John put the ball in the box and then left for work, while Mark put the ball in the basket and then left for school. Therefore, the ball is still in the box when John and Mark came together later in the day. So, which is not correct, because John would think that it's still in the box, and Mark would think that it's in the basket. So that was the expected output, but we got this wrong. But this is okay, because even models like GPT 3.5 failed with this, so I think that's kind of expected. So the next thing we try is, we are trying a code. So we give instruct, and I asked it to write, like, this is a very basic example. Write Python code to reverse all the characters in a sentence. So I give a sentence like hello world, and it should reverse each of the characters and print it. So here it does a good job of also giving the sample output and also giving a clear explanation on why it wrote this code. So I just copy pasted this code, and then this is the output that we see. But this is like a very basic thing, so it worked, but we'll still have to check for more complicated versions of coding. And the next use case we see is topic modeling. So topic modeling basically means that we have a paragraph or a piece of text, and we want the model to identify the main topics in that text. So if you can read this quickly, it is about sustainable energy and how solar power can be used to become more sustainable. And we ask the model to identify the main topics from the text. And here it does a great job, because if you see, it gives us some 8 topics which are very relevant: renewable energy sources, solar power, climate change, and so all these topics are relevant, and it nicely gives them in a list. So this is great. And next we test how well the model can summarize. So this is again a paragraph about how AI is being leveraged in healthcare, in the field of healthcare. And I've asked it to summarize this text in 1 or 2 sentences. And it does a good job of it. and it gives us this output. AI has shown significant promise in healthcare by leveraging machine learning algorithms and big data analytics to enhance medical diagnosis, streamline administrative tasks, and improve patient outcomes. So I did it in one sentence. I asked it in one or two sentences, so I think this has worked well. And finally, this is I've just asked it to write a poem on machine learning, this is the basic prompt that is available in the script that has been provided in Hugging Face. And yeah, so it writes a nice poem about machine learning. You can read this. So on the whole, I would say it's a great performance for a 2 billion model. But there are obviously room for improvement, as you've seen in this video. But I think a 7 billion version would be far more advanced, and maybe it could have solved our reasoning question, which was kind of tricky. So that's it for today's video. I hope you found this exploration of Google's Gemma 2 billion model interesting. If you have any questions, or if there's a specific AI topic you'd like me to cover in future videos, let me know in the comments below. Thank you for watching, and see you in the next video. And don't forget to like, share, and subscribe to AI Portal for more insights into the world of AI. Stay tuned. Thank you.